Hi, I'm Haley, and I'm a biology major and chemistry minor on the pre-med track, and I will be a senior this year at UNC. Outside of academics, in my free time, I enjoy running, hiking, and painting. I'm really excited about the opportunity to potentially be a chemistry peer mentor this semester because I really just want to serve as an outlet for students to feel comfortable approaching when they may be nervous going to the professor. I know when I was taking orgo and analytical and biochem, I would be nervous going directly to the professor for my questions because I wanted to seem like I knew what I was doing and had everything correct in what I was saying. So having peer mentors really allowed me to have a stress-free environment to ask questions, and I really want to serve as that type of approachable outlet for another student. And I really think that the relatability of having peers in a class that have been through these courses very recently is super helpful to the students to get that perspective as well. I think for transitioning back to in-person classes, I will be an asset as a peer mentor because since I am a senior, I've had a year and a half experience of in-person classes and taking some of these harder science classes in person and online. So I kind of know some of the differences between the in-person and the online that some students may not realize as they're transitioning, that I can kind of give them some tips and tricks for transitioning. And I also am super excited to go back in person. So, students that are nervous or anxious, hesitant about the transition, I just want to help them feel that excitement and be able to ease their nerves in any way that I can. But other than that, I'm just super excited for the possibility to be a peer mentor and form relationships with students in person and just create this supportive mentor student atmosphere this semester. So now I would like to show how to conduct a problem for organic chemistry.
Okay, so now I'm going to go over one of the first things we learn in organic chemistry, which is how to count hydrogens giving a structure. So each vertice represents a carbon, and each carbon has a varying number of hydrogens on it. Every carbon wants to have 4 bonds because in its neutral state, it has a full octet. Therefore, it has 8 electrons, and each bond has 2 electrons in it. So let's start with this carbon right here at our first vertice. So it's bound to one other carbon, so we can know that it has 2 electrons right there. So to complete its octet, it must have 6 more electrons and 3 more bonds, since we said that carbons like to have 4 bonds total, and it has 1 bond there. So we will use red and say it has a hydrogen, another hydrogen, and another hydrogen, because in structures, hydrogens are drawn implicitly. So now this carbon has 4 bonds, 1, 2, 3, 4, and a full octet, with each bond having 2 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now, this carbon is bound to 1, 2, and then a double bond, again, 3. So it already has 3 bonds. Therefore, it only is bound to 1 hydrogen. Now we can count the electrons just to make sure. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now this carbon, it's bound to 1, double bond 2, 3, therefore it's only bound to 1 hydrogen, same as the last one, and let's double check. 1, 2, 3, 4, 5, 6, 7, 8. Now, this carbon is bound to 1 carbon, 2 carbon, 3 carbon, and then a double bond, 4. So it doesn't have any hydrogens. Let's count to make sure. 1, 2, 3, 4, 5, 6, 7, 8. Has all 8 electrons. Okay. Now this carbon has 1, 2, 3 bonds. So it has 1 hydrogen. Now counting the electrons, that's 1, 2, 3, 4, 5, 6, 7, 8. Now as we can see, this pattern will go on for the rest of this molecule. 1 hydrogen here because this carbon has 3 bonds, 1, 2, 3. This carbon has 1, 2, 3 bonds, so it has 1 hydrogen. This carbon has 1, 2, 3 bonds, so it has 1 hydrogen. And finally, this carbon has 1, 2, 3 bonds, so it has 1 hydrogen. And to double check yourself, you can always count your electrons and make sure that each carbon has a full octet in its neutral state. But that's how you count how many implicit hydrogens are in your molecule. So this molecule has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens.